I am Professor Sukruti Joshi from Department of Applied Science Chemistry at Royal University Ahmedabad. Today we are going to learn about preparation of solution. Now before learning about how we can prepare the solution, some of the basic definitions should be known to us. From that, some is that like solution, solvent, solute. From that, a solution is a mixture of two or more substances in a single phase. Here you can see that this is solute, this is solvent, and this is the molecule or the molecular structure of that solute. Second is, in the solution, one constituent is known as solvent while another constituent is known as solute. Here same thing, this is the solution which contains your solute also and solvent also. That thing is known as solution. Now solute is the thing which is dissolved in the solvent. That thing is known as solute, while solvent is the thing in which solute has been dissolved. So here you can see that the solute is going to dissolve in the solvent. Dissolve the solute in the solvent. That thing, this thing which is dissolved in the solvent is known as solute, while in which the solute or any other compound is being dissolved is known as a solvent. From that, the basic definition of what is the solute, what is the solvent. Solute is a substance that are dissolved in anything or in the solvent is known as solute, while solvent is the thing in which something is dissolved, or you can say solvent is the compound or is the solution or is the liquid in which you are dissolving your solute. Normally when we are taking an example of sugar water, at that time sugar is the solute while water is the solvent. Now one of the example of our routine life is given here, that tagged drink. If we can take an example of tagged drink, that is a chemical solution basically in which there are two constituents are there. One is solute and another is solvent. Solute is actually the powder thing which is dissolved in the water. So here tang mix, which is in the powder form or which is in the solid form, is known as a solute, while water is a solvent in which your tang mixture is dissolved and the total thing or the total mixture is known as solution. So here your tang mixture is a solute, water is a solvent, while the tang drink is known as a chemical solution. Same way, another example is of sugar water. When you are taking 1 tablespoon of sugar and add it into the water, then the sugar is known as solute, while the solvent is known as, the water is known as solvent. And when you are getting your whole sugar solution, that is known as solution, which contains sugar and your water both. So here sugar is solvent, sugar is solute, water is your solvent, and the total sugar water solution, that is a solution. This contains both your sugar also and your water also. Now few of the examples are given when different type of solutes and different type of solvents together and how they form their solution. From that, when you are taking a solvent, a liquid as a solvent, a solid as a solute, then how can you get your solution? That is a sugar water. The example of that type of whole solution is a sugar water solution. Now ethyl alcohol and water, the mixture of ethanol and water is an example of another one in which the solvent is liquid and the solute is also liquid, while the third one is where the solvent is liquid and your solute is gas. At that time, which thing you are getting is your CO2 water, carbonated water. In our cool drinks or any other things, you are getting such type of solution only. Few of the definitions has to be known, like solutions can be classified into two types, saturated solution and unsaturated solution. Now what is the saturated solution? A saturated solution contains the maximum quantity of solute that dissolves at that temperature, and an unsaturated solution is a solution which contains less than the maximum amount of solute that can be dissolved at that particular temperature. Here the difference is like that. In a saturated solution, you cannot add any other solute in that, while an unsaturated solution is the solution in whose maximum capacity is not over and yet to add another things, like you can add any other solute in that so that it can be dissolved in your unsaturated solution. Now this image shows you the difference between a saturated solution and an unsaturated solution. Here you can see that the total solution, in your total solution, number of solutes are more, while here in unsaturated solution number of solutes are less. Here the maximum capacity is over, while here the maximum capacity is not over. Yet you can add another solutes in that and it can dissolve in this, but here you cannot add any other solutes in that and the maximum capacity of the solution is over. Now if we take 30 grams of NaCl and dissolve it in 100 ml of H2O, you are getting a solution which is unsaturated and that contains basically 100 ml of H2O and 30 grams of NaCl. While in same way, if you take 40 grams of NaCl and add it into 100 ml of water and you are dissolving this thing into this, you are getting one solution. So here it is a saturated solution and another few solutes are remaining here. Why? Because it is the saturation point of the solution is over and now it becomes a saturated solution, while the remaining portion cannot be dissolved in that and it remains as it is in the solution. So here saturated solution which contains 100 ml of H2O and 36 grams of NaCl, while the additional 4 grams of NaCl remains as it is. Here you can see that 36 grams of NaCl is basically its saturation point. After that it cannot dissolve any other solutes in that, therefore the remaining 4 grams are remain as it is. Now when you are going to prepare the solution, at that time we have to know that certain terms and certain terminologies which help us to prepare our solution, which help us to get concentrations of solution. So here from that first is mole. What is a mole? Basically each and everywhere mole is a very basic unit which is used to quantify any of the substance in the world. So here what is a mole? A mole is defined as the quantity of substance that has the same number of particles as it is found in 12 grams of carbon 12. Here a mole is defined as a quantity of a substance that has the same number of particles which as is found in 12 grams of carbon 12. Mole can be differentiated, mole can be determined by this formula. Mole is equal to weight of a sample in grams divided by molar weight. Here the weight of a sample which you are going to dissolve in your solution, it is divided by its molecular weight and you are getting your mole. Now before that we know that what is the Avogadro number. The Avogadro number is 6.022 into 10 raised to 23. That is the unit value of this Avogadro number. Now the mass in grams of 1 mole of compound is equal to the molecular weight of the compound in atomic mass unit. Any of the atomic weight is measured in atomic mass unit, a standard unit which is used to measure atomic weight of any of the elements. That is known as AMU, atomic mass unit. Now for an example, we are taking one example, one reaction, that is 2H2 plus O2 gives 2H2O. 2 mole of dihydrogen H2 and 1 mole of dioxygen O2 reacts with each other to form 2 moles of water. The mole may also be used to express the number of atoms, ions or any other elementary entities in a given sample of any substance. Here you can see that 2 moles of hydrogen and 1 mole of oxygen get together to form 2H2O, 2 moles of water. So here the above number is 2 is that mole, 1 is mole of oxygen and 2 moles of water you can get. The second term is molecular weight. What do you understand by molecular weight? That thing has been explained here. The molecular weight is of a molecule is calculated by adding the atomic weights of atoms that are present in your molecule, number of atoms that are present in the molecule. And as we know that atomic weight of any of the element is being written in atomic mass unit, or you can say in AMU. The total sum of that all atomic weights is known as molecular weight. For example, the molecular weight of methane, if we are calculating here the molecular weight of methane, we can see here that we know that molecular formula of methane is CH4. So from that we can know that one atom of carbon is there and 4 atoms of hydrogen is there. So from this table we can find, like, carbon has atomic weight or atomic mass 12.011 AMU, hydrogen has atomic mass of 1.000794, and the total mass, because here 1 atom of carbon is present, here 4 atoms of hydrogen is present, so you have to calculate like that way, and you are getting here 12.011 and here 4.03176. Like, when we get CH4, the total molecular weight of this molecule, or you can say the molecule methane, you are getting the sum of all these atomic weights, that is 16.043. This is known as a molecular weight of your CH4, your methane. Now when you are going to prepare various concentrations of the solutions, at that time some of the terms or some of the things that need to know. From that, first is normality. What is a normality? So here, number of equivalents of solute that are present in 1 liter of solution is known as one normal solution, and that term is known as normality. Normality can be represented by the formula capital N is equal to equivalent of solute divided by volume of solution in liter. Here normality is represented by capital N. When you are calculating in your practical ways, at that time this formula has been helped you, like capital N is equal to mass of solute into 1000 divided by equivalent mass of solute into volume in ml, or you can say in liters, whatever you are using. If you put the values of all these things, mass of solute, equivalent mass of solute, volume in ml, then you are getting what is the normality of that particular solution. So here also N is equal to equivalents divided by V in liters. This formula can also help you to find out the normality of any of the solutions. Here we are taking example of normality. How can you find out the normality? If the other values are given to you, how can you find that what is the normality of this solution? So here we are taking an example, that is, find the normality of H2SO4, having 49 grams of H2SO4 present in 500 ml of solution. Here you can see that you are given mass of solute 49 grams, last volume of your solution in ml, that is 500 ml, and you have to calculate the normality of this H2SO4 solution. So here, as we know that this is the formula of normality, capital N is equal to mass of solute into 1000 divided by equivalent mass into volume of solution in ml. So here we are putting that values, capital N is equal to 49 into 1000 divided by 98 by 2 into 500. Here the equivalent mass can be calculated by the molecular weight divided by its acidity. So here we are taking H2SO4, therefore we are dividing it by 2, and that in that way we are getting our value, that is 2 normal. So the solution which we are getting is 2 normal solution. Another term is molarity, amount of molecular weight of the solute present in 1 liter of solution, that is known as molar solution, or you can say 1 molar solution, and that phenomenon whole is known as molarity. Molarity is represented by capital M, and the formula is given here, capital M is equal to weight of solute per liter divided by molecular weight of solute. From here you can calculate any molarity of any of the solution. The practical formula which is given is capital M is equal to weight of solute into 1000 divided by molecular weight of solute into volume of solution, either in ml or either in liter, whichever you are using, that you can put it here. Now example of molarity. Calculate the molarity of the solution of NaOH in which 0.40 grams of NaOH is dissolved in 500 ml of solution. So here you are given 0.40 grams mass of solute, or you can say weight of solute, 500 ml of solution, volume of the solution in ml, that is 500 ml, And when you are putting the values in your molarity formula, then you are getting your answer. Capital M is equal to 0.40 divided by 40 into 500 into 1000, and you are getting your value, that is 0.02 molar. This value is known as molar. You have to represent molarity in the molar only. Next term is molality. After molarity, you are getting the next term is molality. Here the difference is only like that. There you are taking 1 liter. Here we are taking 1 kg. See here, molecular weight of solute present in 1 kg or 1000 grams of solvent is known as 1 molar solution, or you can say a molality of that solution. It is represented by small m, and the formula which is given is small m is equal to number of mole into 1000 divided by weight of solution. This is the practical formula which is used to calculate the molality of any of the solution. Small m is equal to mass of solute into 1000 divided by molecular mass into mass of solvent in grams. Now, various concentration in terms of percentage. It can be given by, it is represented in 3 ways: weight by volume, percentage weight by volume, percentage volume by volume, and third is percentage weight by weight. Here, first term is percentage weight by volume, that is percentage by mass. It can be also known as percentage by mass is equal to mass of solute divided by volume of solution into 100. You are taking here percentage, therefore we are multiplying this whole term with 100. If you put these two values here, you are getting your percentage weight by volume. Next is volume by volume. So when you are calculating percentage by volume, the formula which is given is equal to volume of solute divided by volume of solution into 100. Now we are taking some of the examples of weight by volume and volume by volume. What is the weight by volume percentage concentration of 250 ml of aqueous sodium chloride solution containing 5 grams of NaCl? Here you have to calculate W by V, that is your weight by volume, percentage weight by volume. So here mass solute divided by volume of solution into 100. So mass solute, the number of mass, or you can say the weight of the solute that is dissolved in the solution is written here. Therefore mass solute is equal to 5 grams. Volume of the solution, the total volume of the solution which is given is 250 ml. So you are getting here 250 ml. Now if you calculate from here, that is 5 grams divided by 250 ml into 100 is equal to 2 grams by 100 ml. Here weight by volume, your value is 2 grams by 100 ml, percentage weight by volume. Now same way, the third term is weight by weight, percentage weight by weight. So here if you have to calculate this, you can calculate it from this formula: percentage by mass of solute is equal to mass solute divided by mass of solution into 100. First example of this is an example. Consider 5 grams of sugar is dissolved in 20 grams of water. What is the weight by weight percentage concentration of sugar in this solution? So here, as we are having this formula here, we just have to put the values in this, and if we put the values of this, like 5 grams of sugar is there, your mass of the solute divided by your mass of solution, the total solution which contains water also and sugar also. So here the total 25 grams of solution is there into 100. You are getting 20% weight by weight. This is your final answer. Now fewer examples are there, like calculate the molarity and normality of a solution containing 0.5 grams of NaOH dissolved in 500 ml. So here first you have to calculate molarity. How can you calculate molarity from here? Molarity is equal to mass of solute divided by molecular mass into 1000 by volume in ml. So we are putting just only the values from here. We know that mass of solute is 0.5 grams, molecular mass is 40, of NaOH is 40 into 1000 divided by volume that is given to you, that is 500 ml. If you put all these values and calculate the total value, that is your 0.025 molar. First answer is your molarity. Second is normality. Capital N is equal to mass of solute into 1000 divided by equivalent mass into volume in ml. So here you are putting these values. 0.5 mass of solute divided by 40 by 1, that is your equivalent mass into 500 into 1000. As you know that volume of your solution is 500 ml, therefore you are getting the value is 0.025 normal. Now for monovalent compounds like NaOH, the normality, the value of normality and molarity both are same. Another example is given. 20 ml of 10 normal HCl are diluted with distilled water to form 1 liter of the solution. What is the normality of that diluted solution? So here we have already the formula, that is N1V1 is equal to N2V2. We have to put only the values in this, that 20 by 1000 into 100 into 10 is equal to N2 into 1000 by 1000. You are getting the value, your normality is 0.2 normal. Thank you.